Today is March the 3rd, no, the 4th, sorry. March the 4th, 2020. And we're going to be talking about exponential growth and exponential decay in real-world scenarios or word problems. The formula we're going to be using is P equals A parentheses 1 plus, when it's growth, we're going to be adding R raised to the T. So in this formula, the important thing is to understand what the variables stand for. Okay? It is A is the initial value or the starting value. R is the rate, and that is going to be usually the percent increase or decrease. Careful though, make sure you change that to a decimal. Okay? And T is going to be time. Time, which in our equation, when we've seen it already, it's going to be our x, which is our exponent in this case. And remember, x is independent and time is always the independent variable. All right? Okay, so let's look at the scenario. It says the original value of an investment is $1,400, and the value increased by 9% each year. Use an exponential growth function to find the value of the investment after 25 years. So there, our initial value or starting value is $1,400. Our rate is 9%, but we're going to write that as 0.09. If you're not very good at percentage, you could just put in the calculator and divide by 100, and that'll give me 0.09. Or you could also just move the decimal to the right, if our percent is 9, you move a decimal from here to the right twice, and that's how you could change it from percent to decimal. And actually, I found out that if you go to the calculator, if you go to a calculator page, and you do 9 and control enter, no, not control enter, gosh, I don't remember. Well, there's a percent sign somewhere, and they just showed me last period, and I cannot remember it. Okay, sorry, I owe you that one. All right, let's go back. Then we're going to look at the time. Time is 25 years. So we're going to plug it into the equation. P equals 1,400, parentheses 1 plus our rate. Make sure you put that 0.09, not 9, but 0.09, raised to the 25. And then we would go and plug it into our calculator. I'm going to open a calculator page. We're going to put 1,400, parentheses, there we go, no, 1,400, not 1,000. Parentheses 1 plus 0.09 raised to the 25. Okay. Careful though, because that only shows me 0.3. But if you click on it and hit enter, you actually see the whole value. And it should be 0.31. Since it's money, we want the 31 cents. Oh, one quick thing. Before you plug it into the calculator, make sure you add the 1 to the 0.9. The reason why I want you to do that is because this is what it's going to look like in your test. If you have answer choices that you have to match to the problem, they're going to give you answer choices, but they won't give you 1 plus 0.09. They'll give you 1.09. Okay, that's what it's going to look like. And then that's how you would choose it. If you had answer choices, then you plug it in. But most of the time, they stop at the equation. So there's our equation. So please write that in your homework. All right, our answer is $12,072 with 31 cents. We stop at 31 because money usually has 2 decimals. All right, number 2, A equals 12,000. We're going to pay tuition, and it's going to be increasing by a rate of 6%. So you change that to 0.06, right? Because it's percent. And then time, it wants to know what is it going to cost after 4 years. So time is 4. So P equals 12,000, 1 plus 0.06 raised to the 4th. And please do me the favor of writing in your homework the 1 plus 0.06 already together, which I almost missed it. So it's 1.06. Then plug it into your calculator. 12,000 parentheses 1.06 raised to the 4. Okay. Again, it's money, so click up, hit enter so we can see the whole value. And we only want it to the second decimal. So it's $15,149. That's my dollar sign. It looks ugly, sorry. With 72 cents. Please round properly. All right, let's do number 3. Okay, so far not too bad. I think most people were getting this pretty quickly. Let me do 3 more, or, well, let's see. Yeah, let's do the next one for sure. All right, number 3, it says you're going to have student athletes. We're starting with 300 in high school. And it's going to increase at a rate of 8%. So I'm just going to change that already to decimal, 0.08. And then it says we want to know how many athletes are going to be after 5 years. So this is increasing, right? So then we're going to do P equals 300, which is my initial value, which is our A. Then it is 1 plus 0.08 raised to the 5. So already put that together, 300, 1.08. 0.08 raised to the 5, and let's plug that in. 300, 300, parentheses, 1.08 raised to the 5. All right, on this one, I don't have to click up. Our answer is 440.798, but we're talking about athletes. And athletes are people. We cannot have half a person, and people we cannot round up. Okay, so we're going to leave it as 440 students. All right, so just remember that one. Number 4, we have an annual salary of $149,999 annual sales. So it's money. It's going to increase at a rate of 6%, so 0.6, and it wants to know how much it's going to be worth after 7 years. So how much is it going to increase after 7 years? So let's plug that in. 149,999, 1 plus 0.06 raised to the 7, so 149,999, 1.06. Careful on the calculator, make sure that you don't put a comma, because if you put a comma, it'll give you an error. So that's 1, 2, 3 9s, parentheses, 1.06, close parentheses. The button under the equals is our exponent, and 7. Enter. All right, because it is money, go ahead and click up, hit enter, so you can see your whole value. So this investment is going to increase to $225,543.04. Okay, so money again. All right, so I think we're good on that one. Careful on problems like number 6. On number 6, you actually have to figure out the time. So they don't give you the time. So A is 285, R is 0.75, but time, it tells you you're going to start in 1985, and then you're going to want to figure out how much is it going to be in 2008. So in order for you to figure this out, you're going to subtract them. Okay. So 18 is 7, right? That's a 10. And this would be a 9. Well, yeah. So, I don't even know what I'm doing, but sorry guys, I just being lazy and I'm going to type it in. Okay. What the heck? Why did I get that wrong? Wow, please don't go back. Oh my gosh, I don't know why I wanted to borrow. It was just 3. Wow, no wonder it looks so weird. All right, 23, my bad. And I just did it too, and I knew it was 23. And then you type it in. Make sure that you don't round up because it is subscribers. So that is 285, 1 plus 0.75 raised to the 23. So 285 1.75 raised to the 23. Then you type it in. Okay. All right, and then click up so you can see the whole number, and it's going to be a lot of people. So there is going to be I think it's 1100,845,988. And because it's people, we don't put decimal and we don't round out. So we leave it like that. All right, on the back side, we are doing exponential decay. So decay, you're going to be noticing the difference between growth and decay is that these word problems have keywords that mean that it's decreasing. It'll say decreasing, or words like depreciation, loss. So those will give us a hint that we're going to have a decay. And very similar formula, pretty much the same thing, except we subtract the R. Okay, so A again is the initial value or starting value. R is the rate, which will be given to us as a percent, but we change it to a decimal. T is time, and that is our X, or our exponent. All right, so we're starting with 1,300 people. Our rate is 1%, and our time is from 2000 to 2008, 8 years. So we're going to use the equation again. So 1,300 is our A. 1 minus, because it is decreasing, the rate, and the rate is 0.01. Sorry, I didn't change that to a decimal. 0.01, right? 1% is 0.01. Then we're going to raise it to the 8. Very, very important. Please, please, please do the 1 minus 0.01 first. Because in our test, they're not going to give you this first equation. They're going to give you the second one. So make sure you write the second one. And then let's find our answer. 1,300 parentheses 0.99. Oops, sorry. Just realized I still have the number there. 1,300 parentheses 0.99 raised to the 8. All right, again, this is actually talking about population, not money, population. And it's people, so I don't need to get the decimals. And we don't round people up. So we leave it like that. That's how many people we'll have in our town. Next one, same thing, but now it's money. And let's see if the video doesn't cut me off. But our A is 18,000 for a car. The R is 12% or 0.12. And the time is 10 years. So 18,000 is our A. 1 minus 0.12 raised to the 10. So P equals 18,000. Please, please, please make sure you do 1 minus 0.12 and put it as 0.88 because that's what it's going to look like on the test. Then you can plug it in, 18,000 parentheses 0.88 raised to the 10. So after 10 years, this car went down from $18,000 to $5,013.02. Okay. Since it's showing me the decimal, I don't have to click on it. Let's see if I have time to do one more before it cuts me off. Wait, went too far. Oh, there it is. All right, number 9, A, we're starting with a tractor worth $50,000. R, it's depreciating by 10%, so 0.10 every year. And we want to know what will be the value in 7 years. So P equals 50, 1, 2, 3, 50,000. Then 1 minus 0.10 raised to the 7. So P equals 50 and 0.90 raised to the 7. All right, type it in. 1, 2, 3, 0.90 raised to the 7. All right, so it is worth, and I don't see the cents, so click up, hit enter, because I wanted the ones too. And it's going to be worth $23,914 with 85 cents. That would round up. right? Because of the decimal next to it.